Alright, 2.4, use postulates and diagrams. A line perpendicular to a plane. I'm going to write this out and then I'll talk about it a little bit. A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects that point. Remember, this little symbol means perpendicular, and IFF means if and only if. So, what this is saying is that if you have a plane and there's a line that is perpendicular to that plane, that line intersects the plane in one point, and any other line that intersects that point is also going to be perpendicular to the line. Okay? This is kind of a crude drawing. You have to kind of think three-dimensionally here. Any line I draw through that point is going to be perpendicular to this line going up and down like this. Okay? Alright, let's go over some postulates. Postulate 5. Through any 2 points, there exists exactly one line. So if you have this point and this point over here, you can draw exactly one line through both of those points. Okay? Likewise, a line contains at least 2 points. So if you have some line drawn, there's at least 2 points somewhere on that line. If 2 lines intersect, then their intersection is exactly 1 point. So if this line were to intersect this other line, they're going to intersect at 1 point. Alright. Through any 3 non-collinear points, there exists exactly one plane. So if I have this point, and some other point, I can draw a plane through all 3 of those points. Exactly one plane. Okay? The same way, a plane contains at least 3 non-collinear points. So if you have a plane, you can find at least 3 points that don't make a straight line somewhere in that plane. If 2 points lie in a plane, then the line containing them also lies in the plane. So, if this point and this point both lie in the plane, this line is also in the plane. If 2 planes intersect, then their intersection is a line. I'm going to try to draw this here. This one, and let's see here. If these 2 planes were to intersect, their intersection would be this line. Kind of. I meant to line it up with that dotted line. Okay? Alright, state the postulate illustrated by the diagram. If, looks like we have 3 non-collinear points, then it looks like these 3 non-collinear points are contained inside a plane. So this would be postulate 8. Through any 3 non-collinear points, there exists exactly one plane. Alright, let's go on to page 2. Use the diagram to write examples of postulate 9 and 11. Postulate 9. Plane Q contains at least 3 non-collinear points. So if we looked at this plane, that's the shaded plane Q. Let's see, we have W, we have V, we have Y. All 3 of those points are in the plane, but you can't draw a line through all 3 of them. They are not collinear. That's a Y. There we go. Okay, postulate 11. The intersection of plane P, that's this diagonal plane, and plane Q is this line, line B. Okay? Alright, I'll let you guys do the checkpoint. Concept summary, interpreting a diagram. When you interpret a diagram, you can only assume information about size or measure if it is marked. Okay, so in a diagram, sometimes it looks like certain things are true. But unless it's marked, unless it's labeled, or you're able to tell from the information given, you cannot assume that certain things are true. Now, there's actually a mistake here. This is supposed to say you can assume. Okay, so these are things you can assume. These are things that you cannot assume. So go ahead and make that correction in your notes. You can assume that all the points shown are coplanar. You know they're coplanar because they're all contained in this little rectangle here, in plane P. Angle AHB, that's this angle here, and angle BHJ are a linear pair. From the diagram, you can tell that those two angles make a straight line, so you know that they're a linear pair. Angle AHF and angle BHJ are vertical angles. That is something you can assume from the diagram. It's obvious from the diagram that these two are vertical angles. Angle AHJ and D, these 4 points, are collinear. You know that they're collinear because there is an actual line drawn through all 4 of those points. If there was no line drawn, you could not assume that they're collinear. Lines AD and BF, here's AD, here's BF, intersect at H, point H. You know that they intersect there. Those are all things you can tell from this diagram. Here are some things you can assume. You can't assume that G, F, and E, these 3 points, are collinear. Maybe in the diagram they look like they might make a straight line, but because there is no line drawn through those 3 points, you can't assume. Line BF and CE intersect. Line BF and CE, it looks like if they continue on, they might intersect, but because it's not shown, you can't assume. Neither can you assume that they do not intersect. You can't assume that these lines are parallel because you don't have those little parallel arrows there. You can't assume that angle BHA, that's this angle, is congruent to CJA. You can't assume that these two angles are equal or congruent. It might look like they're about the same size in the diagram, but they might not be. Okay? You can't assume that AD is perpendicular to BF. You can't assume that these make a right angle because there is no box there. Or that angle AHB is 90 degrees, so pretty much the same thing. Alright? Because those things aren't labeled, we don't know. So you can't assume those things. Okay? Alright, let's go on to page 3. Okay, sketch a diagram showing RS perpendicular to TV, intersecting at point X. Okay, so we drew, or actually it's kind of already drawn for you, RS, and we labeled those points. Point X is drawn here between R and S. Remember, between means it's collinear with these two and in between them. And then we drew TV through X so that it is perpendicular to RS. And we know it's perpendicular from this little box. Remember, this box means it's 90 degrees. Okay. Excuse me. Example 4. Which of the following statements cannot be assumed from the diagram? Okay, E, D, and C are collinear. Here's E, here's D, and here's C. There is an actual line drawn through all 3 of those points, so we know for a fact that they're collinear. The intersection of line BD and EC is D. So here's BD, here's EC, and it is shown in the diagram that they intersect They intersect right there. So that one checks out too. BD is perpendicular to EC. BD is perpendicular to EC. There is no box drawn. It looks like they're perpendicular, but because there's no box, we don't know that they're perpendicular. So this is the one that cannot be assumed. Okay? Likewise, line EC is perpendicular to plane G. EC perpendicular to plane G, we don't know. So those two. With no right angles marked, you cannot assume that BD is perpendicular to EC or EC is perpendicular to plane G. Alright, I'll let you guys do these last couple checkpoints, and that's all for today.